Alright, hi, I'm John Donnelly. This is my video walkthrough for my Teaching for Understanding annotated planning template lesson plan. Covered name already. Grade is weird. I'll be teaching at Ocoee High School, Algebra 1 and Geometry Honors. This lesson is focused on just the Algebra 1 aspect of that. So could be ninth grade. I'd say predominantly ninth grade, some 10th. But when I got interviewed, they said that this is the math class required. It's a graduation requirement. So I'd imagine there are some juniors and seniors who are in the class also who may have just put off the algebra. So this lesson in particular is going to cover the properties of real numbers, and it's going to be the first, within the first week of classes, I think, is when this would really come into play. A class is 50 minutes long. Whether this will all cover, this will just be one 50-minute session, or maybe the very last part of it will spill over to a second day. That we'll just have to see when I'm actually teaching. And as far as the standard, I mean, it's a really long, complicated symbol, lots of letters, but the standard it's going for is explaining each step in solving a simple equation as following from the equality of numbers asserted at the previous step, starting from the assumption that the original equation has a solution and constructing a viable argument to justify a solution method. That is one standard in the math content section. This is going to be more towards expressions. So this is introducing the stuff. The same properties are going to be used to solve equations later on. This is the very introduction of it. This is just when it's still expressions. So my lesson, first of all, it's important. The topic's important, all these properties of real numbers, in order to manipulate, simplify expressions. And you'll also do that for algebraic equations a little bit later on, like very soon after this. And are you going to have to just identify which property of the real numbers you're using in real life and in any problems ever? No, you won't. But it's important to know what they are so that, well, first of all, you need to know what they are. You need to know that they exist. So when you're doing something, you know why you can. You don't have to get into the technical, well, technically I did this. That you can skip steps when you get the hang of it. But at the very beginning, you want to have a good basis of what you're doing. You want to have a good system going on. And this is how you do step by step how to solve equations, simplify expressions. So that's what students need at the beginning. And when they get used to it, like I said, they can phase it out. They can skip steps, whatever. And it's important. It fills in the gaps. Now, some other ones, like there's some really trivial identities also, like properties, like the identity property, which is you add 0, it stays the same, or you multiply by 1, and whatever you started out with stays the same, which seems really trivial, but there is a good application for this besides just 3 plus 0 is 3. If you're sometimes when you're solving equations, problems, anything, you have to simplify. You need to group things together. Like, say you had a fraction, you've got 3x on top, and 3x plus 1 on the bottom. What you can do on the top is you could add 1 and subtract 1. And then you can group the 3x plus 1 on the top, cross it out with the 3x on the bottom. So you're just left with negative 1 over 3x plus 1, if you wanted to do that. But you can add 0. You're adding 0, it's really plus 1 minus 1, so 1 minus 1 is 0, so that works out. Same with multiplication, when you want to simplify radicals, which they're simple enough as it is, but really we don't like radicals in the denominator, so you have 1 over square root 2. You can multiply by square root 2 over square root 2, which if you look at that, it's 1, because the top and bottom cross out, that's 1. So it's the same thing, but you change it so it'll be radical 2 over 2, which is a more acceptable form, because for some reason some people don't like radicals in the denominator. So how am I going to teach it? Well, the start of the lesson, I'll give them a really simple expression that hopefully all of them will be able to get a good confidence booster. Maybe they'll laugh and say, wow, is this what high school is like? This is what algebra is like? I can do this. So confidence, like I said. So just fun, just an easy start. So what's 1 plus 0? It's 1. What's 2 plus 0? It's 2. And so why is that? Why is 1 plus 0 still 1? And they'll say, because 0 is nothing. But 0 is the additive identity. I just sort of cover this. 0 is the additive identity. If you multiply 2 by 1, you get 2. You multiply 3 by 1, you get 3. So you get what you started with, because 1 is the multiplicative identity. So these are all the terms I'm going to go in. So basically, it's stuff they already know, but I'm giving them official terms that they may not know, not be aware of. And so they get that going. I'm asking them stuff. So while I'm teaching, I'm also asking, I'm probing, they're recalling what they know, and they know it's so easy, and they're adding on new layers of information as they go along. So it's connecting the old with the new, creating better. I think the buzz term there is active processing. So they get that going on. It's going to make better recall. And since they're engaging with me and not just sitting there just writing all the notes down, it's going to be more active. They're going to have a better time, and it won't be as boring as just sitting there taking lecture notes. So they'll get more out of it that way too. So once I talk about the identities, which I just did, I'll swing over to the inverse properties. So I'll ask first, though, what's 1 plus 1? So again, starting off easy, it's 0. Then what's 1 plus 1 is 2. The next part is, okay, what's 1 minus 1? That one's 0, which is what we just covered. It's the additive identity. And why does this happen? This is another part which I think will really hook their attention, because it's something they know, they don't really care, but this is sort of like conspiracy theory in math. I loved this when I found it out, was that 1 minus 1 isn't real. That's not what's actually happening. There's no such thing as subtraction, and likewise, there's no such thing as division, technically. What you have is you can add an additive inverse, okay? So the additive inverse is whatever you would add to a number to make it the additive identity, which is 0. So in case of 1, negative 1 is the additive inverse. So 1 plus negative 1 is 0, and that goes with all numbers. Multiplicative inverse is the same deal. If you have 2, you don't divide by 2 to get 1. You multiply by 1/2, because 1/2 is the multiplicative inverse of 2. So no real division, no real multiplication. I think that'll get them, like, they'll think that's sort of cool, I hope. I thought that was sort of cool. Very conspiracy theory-ish. Alright. So, I'm doing that. I talked about how that's going to work out all the time. I think it'll be a good hook for them. And I think as far as a reference or any sort of graphic thing, most textbooks that I've seen for Algebra 1 have had at least like algebra, and then there's one for geometry, there's one for trig, and for calculus. And there's always a formula sheet or there's a reference sheet. I feel their book's going to have it too. So I'd address it, and I'd send them there to look at that. But even I put in my lesson plan for the Microteach I, I put in a sample of what I would do if there wasn't one. I'd make one up. It's got all the properties and exactly how they work for real numbers, A, B, C, D, and it's just any real number. And yeah, that's all there. I gave that out in the lesson plan in the Microteach. So following from identity and from inverse, we go to the distributive property, which is a little weirder. So I'll ask 1 plus 1, again, it's 2, okay, because you combine them. If you have 2x plus 2x, what's that? Well, some kids, I mean, depending on their algebra background and what we've covered up to this point, they'll go, I don't know, is it 4 plus x? Is it? But they'll know it's 4x, some of them, hopefully, by this point, and if not, I'll get to that. But then I'll give them 2x, and then in parentheses, it'll be 1 plus 1. And then you know what to do. So you could use PEMDAS in this case and say 1 plus 1 is 2, and then 2 times 2x is 4x, and that's good. But I'm gonna go more for distributing the 2x and then adding them together. And so that's what I'm gonna introduce it that way. It's again stuff they already know, 1 plus 1, they know that, and they know PEMDAS, so they can do it without distribution, but I'm gonna show them how to do it with distribution. So again, taking some of what they already know the answer, so they know that when I do this and do it differently, it's the same answer, so that it works, it's legit, it's legal. Okay, still the active learning going on, and yeah. I'm starting with the really easy stuff and going into the newer, maybe you haven't seen it before, and I'm guiding your thinking in there. And as I'm doing that, I'm help bridging connections, scaffolding students to get to the next level of here's where you are, here's where this stuff is. I'm trying to bridge connections, like I said. And then the next one, I wish I had a board somewhere or something that I could do this with, but I'm just gonna have to imagination here. So next is associative and commutative properties. So technically we did associative, no, yeah, no. So if you have 3x plus 2 plus 3x, just like that in a line, what would you do? Most people will combine the two 3x's, so you get 6x plus 2, or you could do 2 plus 3x, either way. And you have y's, well, I combine like terms, and that's great. But technically, we're not doing that, because technically we're working from left to right, and we're working with numbers next to each other. So technically, you'd have to switch the 2 and the 3x around. You'd pair them up, associative property, because having them all out there and pairing 2 of them in parentheses, it's the same thing by associative property. Commutative property, they can commute, they can move, so you swap positions, and then the 3x's are next to each other, so then you can combine them that way. Even you associate them together and then combine them. That's technically all the steps that you would do. So once you get more skilled in it, like I just did that in one step, combine the 3x's. It's really, I shouldn't have picked it 2, because I say 2 3x's. Anyway, you get more advanced, you don't do any of that. There were like 5 steps there, I just did it in 1. So they can do that too, but they need to know why they can do that, and that's where all these steps and properties come in. It's where the logic behind the problem solving and all this reasoning and stuff comes in from the standard. So I'll do a couple more examples of that, and by examples, I mean I'm going to give examples and ask, so what, based on what we just saw, how would we go about doing this? I'll take suggestions. Anyone gets it wrong, I'll explain to them why that's not so, or have other people explain why it's not so. I just want everyone communicating, everyone talking, and so that way it's not just a boring math class. I want people engaged, we want to have a conversation. A lot of the math classes I've been in have been really quiet. I don't like that. So do that. I already said there's technically no subtraction and there's technically no division. So when you're using the associative property and the commutative property, it works for addition and it works for multiplication. Does not work in general for subtraction, and it does not work in general for division, because technically those things don't exist. So the only time it does work is if it's the same number. Because if you have like 2 minus 1, okay, 2 minus 1 is 1. But if you switch it, 1 minus 2 is negative 1. So that doesn't work. It only works if it's the same number. 1 minus 1 is 0. And then switch the ones. 1 minus 1 is 0 again. Same with division. It only works if it's the same. Now, then I saved the best for last. It should be the easiest. If you multiply anything by 0, what do you get? 0. If you divide 0 by any number, what is it? 0. So those are nice. And then I switch it. Say I asked, what's 0 divided by 3? Okay, that one's 0. What's 3 divided by 0? People might go 0, people might go infinity, and I go, well, think about it. I'm asking you how many times 0 goes into 3. We already know you multiply anything by 0, it's 0. So no matter what, even if it was infinity, technically it would never go in there. Although technically infinity times anything is also infinity. So that one's just weird. It's all around weird, and that's why it's not infinity, it's not 0. We say it does not exist, we put D on E. Alright? Now, I have a formative group assessment activity that I'm going to have take place either Now, right after I've covered all that, or it'll take place the next day in class for review. Um, I'm just gonna go ahead and assume we have time. So as I'm putting it in and saying all this stuff, I'll get into what that activity is. So what I'm gonna do is I'm gonna split them into two groups. Okay. Then it's split into two groups. I'm gonna have the class, and they're gonna line up. And each person that they're in line with, you can look over the other line, the same position. That's who you're gonna be up against. I'm gonna have a smart board, or I'm gonna have a projector, or some sort of access so I can put up there. I'm gonna use Quizlet, and Quizlet is an online flashcard website, and I'm gonna put these expressions, and on one side, on the back side is gonna be the properties you would use to simplify them, and I'm gonna have one on the board. The first two in line, when I say go, they're gonna go up to the board, and they're gonna write down the property that they would use. Whoever writes the first one first gets a point, and then if they can do it, they get another point. If they get that wrong, the other team the whole team on the other side can collaborate. The person at the board will give the answer and demonstrate it with the help of the team. And if they get the property and the answer right, they get to steal a point from the other team. So I think that'll be a fun little competitive, active. You're up, you're going around. It's a little bit different than just sitting there or just answering questions. So I think that'll be fun. All right. So there's that, and for accommodations for this, you're gonna have for accommodations for this, there's gonna be, especially this, particularly ESOL, like English language learners. If you're really advanced, there is one girl, Tasir, who was very advanced. She could do practically. She has everything down. She can talk. She just gets a little mixed up if you're going too fast or something like that. So I would go a little. I don't talk that fast anyway, so we wouldn't have a problem there. But I'd give her that chart that I printed out, that I had in the Microteach with all the terms on it, so she can glance at that. If I'm talking about something, she's like, "Wait, what was that?" And it's really big, and she can look. But speed, I don't think she'll have a problem. Intermediate, like Edgar, you can have that chart also. But when we're doing the activity on the board, I'm going to write out like different properties, and he can just go up and circle it. All right. In fact, I might just do that so everyone can just circle it. It might be easier that way. You just got to pick. It's like multiple choice, multiple guess. And then all students have computers, so they've got ebook access. They can pull it up anytime they want, stick it in a translator if they were really confused. And so struggling English language learners like Edith can do that. But me personally, my personal thing that I would do with for students like Edith is, first of all, when I'm asking questions and everything, I would give her the question beforehand so that she can see what it does, she can work through it, and she can think about how she's going to explain it to me. When I call on her, I'm going to give her a chance to phrase her answer. And then just in general, I might have her working with a partner, someone really accomplished, and they might take a few days to figure out who really knows their stuff, who feels comfortable helping her. Maybe she's got a friend, someone who wouldn't get taken down too much by spending some extra time to help her through it. So that she gets experience talking with someone, and she also gets to know the material a little bit too, get some help from a professional in the class. All of these kids, though, will be included in the group activity and in everything else as much as possible, because they need interaction to get the English language going on, all right? And so all of that, the questions in class and the group activities, all guided. That's all under guided practice. Also, when I assign homework for independent practice, any problems that they don't know, they can email to me that night as they're going through or as they're finishing. And before class, I'm going to check my email. I'll get them all lined up. I know there's some websites that can do stuff like this. I just don't know what they are off the top of my head. I'm going to get them together, see which one has been put up the most, and that one we'll go over as a bell ringer or something together. We'll talk the class through it. And so that'll be some more guided practice. Homework will be just more problems from the book. That's traditional homework right there. more Quizlet, especially with definitions and properties and stuff like that. The exact same stuff we looked at in class, they'll have access to. I'm going to have a class access Quizlet site. And so I'll make some flashcards, or students can make flashcards of like practice problems they thought were difficult, put them on there for practice. And eventually, it's not for this lesson, but I'm going to go to Khan Academy at a class up for Khan Academy where everyone can keep track of each other's points and badges and stuff, and they can do more of that. I'll assign modules on there from time to time, and once I figure out how I can see that they did it and completed it and how they did, and they can compete for each other, with each other for the highest score. I think I'll give like the highest 3 or so some extra credit for being up there. I'm not sure exactly yet how that's going to work out, but that would give some extra incentive to go up and do it, especially kids who are really struggling. They'll work on it more and more for the extra credit, and they'll learn something too doing it, so that works. A few days from then, because I told you this is all expressions, a few days in, we're going to be on equations and solving equations. And it's a little bit different, but you're still using the same properties. So for like a quiz kind of project, I'll have students go in and do, again, this is a few days. I'll give them equations. They'll be in groups of 2 or 3, and their task is find the solution to the equation, all the different forms it can take, all the different ways you can get there, and I want you to represent that. It can be a chart with arrows. It can be, you can write a paragraph on it, do a video, PowerPoint. They're all on Macs, so they wouldn't do PowerPoint. I don't know what they would use, but they could do that kind of thing. Anything they want, really. And so that helps with whatever learning styles they have. If they want to do things visually or verbally, they could just do a presentation. They want to do it, they want to write it down. That's all fine. Use technology, make a video, be creative with it. They can do what they want. They'll try a little harder, and that's how that'll work. Yeah, I also mentioned that they all have computer access, so they can use voice to text, text to speech. They can zoom in and out, and I'll have all the stuff posted somehow from class. It'll be much easier for the smart board. All the notes will be on there. They can look at those and zoom in on it. All sorts of good stuff there. So they'll be good on that. What else was there? There was something else. No, that's all the stuff that they can do, yeah. And that covers hearing difficulties, vision difficulties, motor impairments, all kinds of things. So need internet access to do all this. They need the computers that they're going to have, the ebook. I want a smart board. I might not get one, but at least I need a projector with access to my computer. I need a class computer. I might get a free MacBook just like the students. That would be great. I also need the websites of Quizlet and Khan Academy to not be blocked. And yeah, so I kind of covered how all of it's going to be used and useful for students. One thing though with technology is that if kids are doing technology and all these little game things, it's kind of trick them into learning because they like playing on tablets and computers and all this other stuff. The stuff we're doing with technology, the games might trick them into learning. The technology won't, but the fact that you're using technology, especially with Akoi High, which is where I'm going to be teaching in the fall, they're new to the technology. I think they started it last year. So the students there, it's kind of new and exciting still, and they want to see what we can do, what they can do with it. It's not the traditional learning, and I think they'll really enjoy it. It'll get some motivation up, pique some interests, and yeah, that's my fully comprehensive lesson plan. I did not plan it like this. This assignment here was worth 20 points, so I guess there's 1 minute per point or something. It's a little over. I don't know how long it's supposed to be, but it's good 25 minutes, very solid. So in case you didn't get, unless there was anything that you missed from the written lesson plan, hopefully this clarified that. Anything you need more clarification on from the video, I do have a written lesson plan in the Microteach that you can look at. And that's it. Thanks for watching. Thanks for listening. And I welcome your constructive feedback.